Alright guys, welcome back. We have spoken a lot about arrays in the last two sessions, last two videos rather. So in this session, we'll be going through some practice problems to test your understanding of arrays. I highly recommend that you download this workbook and to try them out on your own before referring to the solution. That will be better learning experience for you guys, and it will help you to remember better. Okay, so pause for a second. Hope you guys have done them. Right, let's get on to the solution. So I have one sheet on this workbook. It's called sheet 1. So I'm not going to need this section. I'm just going to close it away. But I'm going to need the locals window. That's for sure. Okay, so remember the locals window is array's best friend. Subtask 1. Okay. So the first question, write a 1D fixed array in VBA for 2, 5, 10. Express in VBA format. This is simple, right? This is simple. We've gone through something exactly similar in the last two lectures. So I'm going to say R equals to array 2, 5, 10. Okay, that's about it. Okay, done question 1. What is the lower bound of this array, 0 or 1? Well, I know this is the VBA convention. So it's 0. Okay, but if you want to test it, all you have to do is click stop, get onto this, and then just run it. Stop at stop and use the locals window to check, to inspect on your own, right? The first element is 0. That's about it, right? Another way to inspect is you could just use debug.print lbound r 1, right? Because it's just one dimensional, so you can negate the 1 if you want, but just like to have it. Okay, I've explained this previously. Okay, that's another way to do it. Okay, that's another way to do it, and you can just run it and you will see that the value 0 has been returned. Okay, I'm gonna run it again. I don't know why there was something in the middle window previously. Okay, so it's 0. Okay, so that's about it. Okay, so question 2, how do we change the L-bound to 1? Don't use the Excel syntax. Right, very simple. I'm just going to name R2 as variant. Okay, we're going to have another. Okay, and of course, since it's a variant, since it's an array, I'm going to have these 2 brackets, right? Nothing in between, right? So all I'm going to do is just say R2. All right, I have 2 since I'm changing it to 1, right? So 1, 2, 3. Okay. Not that it should be nothing, but because we're changing it to 1, that's the reason why we have to set the L bound as 1 and the U bound as 3. So R2 1 equals to 2, R2 2 equals to 5, R2 3 equals to 10, right? So well, we have just changed the boundary. Okay, for the similar array, I just named it as R2. So if I run, stop here, and I refer to R2, I inspect R2, I could see that. Well, and you can see that the first element starts from 1 now. Okay. Similarly, you can also use debug.print lbound. Okay. So I'm not going to prove that to you since we know it's working. Okay. So we've tried it previously, and I've shown it to you in the previous video many times. Okay, so that's one way to do it, to inspect it as well. Okay, now task 3. Now write a 1D fixed array in VBA for 2, 5, 10 in Excel syntax. Okay, so this is one of my favorite. We have gone through this in depth. So just 2, 5, 10, right? 2, 5, 10, I assume it's basically comma separation, right? That's what the question is saying, not assume. We know for 2, 5, 10, comma separation. Okay, so what I'm going to say is dim R as variant. Okay, R equals to 2, 5, 10. Literally, right? That's what it is. Okay, where does the lower bound of this array begin? I know it starts from 1 because Excel convention, right? but I could always prove it to you by just running through it and inspecting in the locals window. So just run it. I'm going to go to the locals window. I'm showing it to you, right? That's one there, right? Starting from 1. Alternatively, I could just do debug.print L bound R, comma 1. That'll be the same thing as well, right? To prove to you that the lower bound starts from 1, right? So one dimensional, and that's all, right? Okay, so that's all there is to task 3 and task 4. Now return the array declared in task 3 into array sheet, into this array sheet at range A34, to A36. Okay, so we're going to return it to A34 to A36. So we are returning it vertically. Okay, we have gone through this before. I'm just going to highlight this. We have gone through this in the previous 2 lectures. Okay, how do we do it? Very simple. If you still remember, to return the array, right? We're returning it vertically. Okay, so what we're going to say is sheet 1 dot range A34 to A36 equals to application dot transpose R. Okay, we have gone through this. So I hope you got this right. Okay, so run the code. Why am I stopping it? I just run it again. I have too many stops, right? So let's going to reset it, right? And let's run it again. Okay, I have 2, 5, and 10, right? That's the vertical returning. If it's going to use the horizontal, then you don't have to use the transpose. Okay, so watch the video if you have missed it out. Okay, or I explained in detail. Now, where is the lower bound? Right, no, we have gone through task 5. Now task 6. Now use the value in range A30 to E30. So I have this range A30 to E30. Okay, and what is it asking me? And reference it into an array. Okay, so this is something that we have covered as well. So it's very basic stuff. Remember when I told you the first rule when you're referencing arrays from worksheet, right, is that they're all 2-dimensional, regardless of whether you have whether you're referencing a 1-dimensional or 2-dimensional arrays, right? When you reference them, it is always 2-dimensional. So it's asking us to reference sheet 1 dot range A30 to E30, right? Am I right? Question 6, right? So I've declared this, I've reference. Okay, now I'm just going to say, remember, we reference arrays from worksheet. It is 2D. That's all. I'm just going to write that for your reference, okay? And then, what is it asking it? And reference it into an array. Okay, so we have referenced it into an array. That's about it, okay? What's the position of C30 in the array? So C30 is C15, number 15, right? So I can tell you that we have 1 row, right? And we have 1 row and 3 column, right? So we are on 1 tree, okay? I just can tell you from inspection is R13, but we're going to use the locals window anyway to just prove it, okay? So I'm just going to run this. So I run the code, stop, I go to my locals window, 1 tree is just 15. Okay, so we've completed this task, right? Task 6 has been completed. Task 7. All right, we've completed task 7 as well. What's position of C30 in the array? Now, task 8. Now, write an expanding. All right, this is getting interesting. We are going to dynamic arrays, right? Expanding arrays, okay? So let's get the mood going. Now write an expanding 1D array for 20, 50, 70, 90, and 100. Ensure the lower bound starts from 1. Okay, this is very, very simple. Okay? Very simple stuff. Okay, what I'm going to do is dim R. Remember, I told you that, right? And we're going to use the keyword anytime you have expanding array. We're going to use the keyword redim R. We're starting from 1, 2. So how many elements do we have? 1, 2, 3, 4, 5. Right? So 1, 2, 5. Yes, just vary. That's just how I like to do it. Okay? And then R1. What's the value? 20. R2. The value is 50. R3. Value is 70. R4. The value is 90. Oh, I'm just trying to do it a little bit faster than I should, because I guess I'm just getting a little bit excited because, well, we have been successfully solving all of the problems. Okay, ensure the lower bound starts with 1. Well, I already know the lower bound starts from 1. Okay, but we can use the locals window to prove it on later. Okay, so now add another entry 120 while retaining all the values. Okay, retaining. Well, you're going to use the keyword preserve, because if we still do redim, all the value gets deleted, right? So let's get redim, preserve, R. We're going to add another entry, right? Expanding entry. Okay, so I'm just going to say R6 is going to be 120. Okay, now I'm just going to stop, and then we're just going to do this annoying entries in the middle window. So I'm just going to run the locals window, run it. It's going to stop, and we're going to check everything. So R1, right? Ensure the lower one starts with 1. We've accomplished that. Okay. Add entry 120. Well, everything is here. Okay. So we're good. We are on track, and we are sailing. Okay. We are sailing. Now, let's move on to task 10. Write a 2D array for 2, 4, 6, where 2, 4, 6 are all in a single column with 3 rows. Okay, right? This is pretty simple stuff, right? So what it's basically saying that 2, 4, 6 are all in a single column with 3 rows. So it's saying something like this, right? So what did I say? Anytime you have more than 1 row, right? Anytime you have more than 1 row in Excel convention, it is a 2D array. Okay, and how do we perform the separation? Semicolon, right? Semicolon, if you still remember. So task 10, right? So dim R as variant. Okay, and R is just going to be, if you've guessed it, Excel convention. Okay, we're going to write in Excel convention. So we're going to say it's 2, 4, 6, and then we're just going to close the curly bracket and wrap it around with the square bracket. Okay, obtain the position of 25. All right, no, obtain the position of 4 in the array. This is very easy stuff. All right, we know in Excel convention, right? If we are filling out in Excel convention, this is 2D. I already know this is 2D, right? So I'm gonna figure it out before we even go into the locals window, right? That's just how we are gonna go, right? Then we're gonna check it out. So I know this is 2D, right? So if I'm just gonna put it here, 2, 4, 6, right? So the position 4, right? We are on the second. We are on the second row and on the first column, right? Right. So in 2D reference, I mean, you have to remember that in your debug.print, right? For a 2D, because this is 2D, considered 2D. So it should be 2 because we're in the second row and first column, right? So I'm going to go with this answer, right? 4 is here. So let's run it and hope that I'm right. Okay. So R, I'm going to test it, check it out. R21, okay, the value 4, okay, so we are spot on, okay. So because this is although it seems like a 1D array, remember this is a 2D array, right? That's how Excel treats it. But if you're going this way, then it's a 1D array. Anytime you have more than one row, 2D arrays. Keep that in mind all the time, right? Never forget that. So obtain the position of 4. Task 12. Write a 2D array for 5, 10, 15 in the first row. Okay? In first row and 3 columns. And 20, 25, and 30 in second row with 3 columns. Write in Excel convention. It's very simple. Okay? This is very, very simple. So we're saying 5, 10, basically something like this. We want 5, 10, 15 in the first row, 20, 25, 30 in the second row with 3 columns. So we have 3 columns here, right, with 1 row. And second row, we have 20, 25, and 30. So anytime we have a row, we are moving to the next row, we are using a semicolon. We are on the same row. We are separating by comma. That's right. Okay. So very basic stuff. We've covered that as well, right? So I hope you got it right. Okay. I hope you got it right. So I'm just going to say dim R as variant. And then I'm going to say R is equals to the Excel convention. Okay, we're going to use the Excel convention for 2D arrays. Okay, because I'm not sure how do we even reference 2D arrays in how do we write 2D arrays in the VBA convention. I know that it's possible to be done on the 5, 10, 15, and then semicolon, 20, 25, 30. Okay. So yes, I know that it can be done on the Excel convention, but on the VBA convention, I only know it's possible for the 1D convention, right? A 2D convention, not that I'm aware of. Okay, and it's not necessary for you to know it either. Okay, it's just not necessary. Okay, because there's so many ways to solve problem. As long as you know the Excel convention and you understand how Excel treats array, you are good to go. I promise you that. So obtain the position of 25 in the array. I'm going to go with my guess again, right? I know that we are on the second row and on the second column, right? So it's just R22, right? Because a 2D array, so debug.print R22 is going to give me 25. So my guess is 2, 2, right? We're just going to inspect it with a locals window, right? So that's the way we can prove that I'm right or wrong. So I'm just going to go stop, let's run. R22 is number 25. Okay, so remember that the first one in a 2D array, right? In a basically 2D array is the row positioning and the column positioning. We've gone through this. Okay, gone through this. So in a 1D array, if you are writing a 1D, then it's only going to show you in one R1, R2, R3. Okay, so for example, so I'm just going to say sub example. This is nothing to do with the question, but I have to just clarify this. Okay, what I meant is if I'm writing something that is one-dimensional, recognized as one-dimensional in Excel, 2, 4, 6, right? And then I'm just going to stop, and then we're going to end this up. Now if I run this, okay, as you could see, it's just giving us this way, right? Yes. But if you're referencing from the Excel worksheet, then remember that everything is always 2D, regardless whether it's a 1D or 2D array, as Excel recognizes them. Okay, doesn't matter. Okay, so just gonna leave this for your reference anyway. Okay, so now let's move on to task 13. We have done task 13. Now task 40. Okay, we are almost towards the end. Okay, fill up the 2D arrays in the range A50, right, to D52, right? I'm going to fill up the 2D in the range A50 to D52 by looping, all right? So we're going to loop through. This is a 2D array. We're going to loop through the row and we're going to loop through the column. I've gone through this in the previous video to each entry. And to return back the array to A55 to D57. So we're going to add 10 to each entry and then return the array back to A55 to D57. Okay, seems very manageable. So we'll just get onto it. Okay, all right. So we're dealing with 2D arrays. Okay, so we have to know how many rows do we have. 1, 2, 3. Okay, and then how many columns? 1, 2, 3, 4. So if this is two-dimensional, so remember, dim R 1, 2, 3, 1, 2, 4 as variant. Okay, because we have 3 rows, 4 columns, so two-dimensional. Okay, now what we're gonna do? We're gonna loop I as long, dim j as long, and we are looping through for I equals to 1, 2, 3. We always loop through rows. Okay, remember that. Okay, and then for j equals to 1 to 4, we loop through columns. Okay, remember that. Then I'm going to say R I j, okay, equals to what are we doing here? Okay, what are we doing here? We are filling up the 2D arrays. Okay, we're filling it up into an array. So I know that I'm filling up, and I'm filling it up by looping, right? So sheet 1 dot cells. What's the cell? It starts from 50, right? So I plus, because we're going from I1, right? So I is plus 49. That's the way we're going to get to 50. And J, column 1 is just A, right? So it's just J, right? So hope you guys understand. Okay, so what are we actually doing here is we are filling up the 2D arrays by looping and adding 10. So we are filling up the values and then we are adding 10, right? That's what we're doing. We're retrieving the values, then we're adding 10 onto it. And as we should be doing, next J, next I. Okay, well, you should be doing something like this. Step 1. Okay, you should do this, because otherwise by default it's still going to consider this to be step 1. This is a good practice. Always specify the step. Okay, now we have populated the thing, right? What we're going to do next, we're just going to return the array back to A55 to D57. This is very basic. Okay, return back. So all we have to do is sheet 1 dot range A55 to D57 equals to R. Okay, so now if I run this, what do you think we're gonna? Okay, it's added 10. It's fill up the array, added 10, and returned it back to A55 to D57. Right? So task 14 completed. Now let's move on to the final task. The final task. Okay, so task 15. Okay, try achieving task 14 by looping through a cell collection. Okay, so we are looping through a collection. What collection do we think is the most ideal? We are looping through a range collection, right? Try achieving task 14 by looping through a cell collection. So we are looping through the cell in a range and returning it to A60 to D62. Correct? So this is something that is relation to looping through cells, right? When we were looping through cells, we've covered that previously. Okay, so what I'm going to say is I'm just going to say dim R as variant. Okay, I'm going to dim R as variant, and then I'm going to just go in to R is equals to sheet 1 dot range. I'm just going to fetch the value. Okay, I'm just going to fetch the value. Remember, I mentioned this in the last lecture. You can just express it as a variant, and then just pick up the value from the worksheet, right? That's exactly what we're doing here. That's exactly what we're doing here. And then I've picked up the value. Now I'm just going to loop through the range, right? So for that, we're going to need a range declaration, right? Okay, but prior to that, what I like to do, right? Because we're returning it back to A60 to D62, right? We're returning it back to A60 to D62, right? So what I should be doing actually is I should actually say sheet 1 dot range A60 to D62 is just going to be array. Okay, so I'm fetching the value. So assume that this I'm fetching the value using the variant, okay, and then I'm transporting it to A60 to D62 because that's where I'm supposed to populate the answer. But so what we're doing is we're returning A50 to D62 this value, right? We're returning this value, but we don't want this value. We have to add 10, right? We have to add 10. Remember that. We have to add 10. That's why we have to loop through the range and then we have to add 10. That's what we have to do, right? We have to add 10 as we loop through the collection. So it's very basic stuff, okay? It's a little bit tricky, but if you've been paying attention, like if you really have been following my lecture, okay, from the get-go and you've been like, all out into it, right? So I'm going to dim C as range, and then I'm going to also have the range declaration, right? Dim RNG as range. And what's our range? We have to use the keyword set, right? Equals to range sheet 1 dot range. I'm just going to say A60 to D62, right? This is very simple. And then we are looping through range, right? So for each C in RNG, it's very simple. We're just going to say C equals to C plus 10, right? C equals to C plus 10, and that's all. That's all to it, right? And we're just going to say next C, right? So the RNG sheet 1, A60 to D62. So what we're doing is we're using the variant array, right? The array that's expressed as variant. We're throwing it into A60 to D62. The value has been returned here, and then we're looping through the cell collection of this range. And then we're just adding 10 onto it. Okay. So if I run this macro, I have 10 addition to all of the entities A50 to D62, or A50 to D52 rather. Right, guys, that's about it. So I hope you got all of this right, or at least most of it. Okay, I know the last question was a little bit tricky, but apart from that, I think the rest was pretty straightforward, and I hope you got them right. And if you did, I suggest you to go back to the last 2 previous videos, pay attention, and make sure that you have all your facts right. But apart from that, as I've said, arrays, although they are something that is difficult to grasp on, it is pretty useful. But as I've said, there are ways to get around arrays, okay? And that is using the virtue of the Excel worksheet, okay? They're very hidden, right? There's a trick, and then just perform your computation there. Basically harnessing the power of the Excel functionality. All right, that's about it, guys. We are done and dusted with array. In the next section, we'll be going through one of my favorite topics, and that is debugging and error handling. I'll see you then. Take care.